Hello students, I hope all of you are fine. So we will start with the first chapter of class 12, that is relation and function. We people are very much aware about the terms relation and functions as we people have discussed it in class 11th. So we will just recall the things that we people have done in class 11th. Recall the notion of relation and function, domain, codomain and range that you people have done in class 11th along with different types of specific real valued functions and their graphs. So if you people remember relation and functions, you people have done domain, you people have done range, codomain, then graphs of some specific functions and their graphs, functions functions and their graphs. So these are few things that you people have done in class 11. So I just make a quick revision of the topics that we people have earlier done. So what is the domain? If you define a relation from set A to set B, suppose this is set A and it has 1 2 3, and this is set B and it has A, B and C. If you define a relation like R is your 1A, then 2C, then 3B. So what does you people mean by the term domain? Domain is the elements, first element of the ordered pair. Domain is the set of first element of the ordered pair. So if you can see the ordered pair 1A, 2C, 3B, the first elements are 1, 2 and 3. So this is your domain. Now we will talk about the range. So what is range? Range is the second element of the ordered pair. So it will be A, C and B, or you can write A, B and C. Next, the term was codomain. Codomain. What is codomain? The whole set second, that is your A, B, C is your codomain. Then you people have done the function graph of the functions, like you people if you people remember the graph of the constant functions, you people have done the functions and their graphs. Then signum function, then you people have done the identity function. So identity function, that was f of x is equals to x. So if you people remember constant function, it was f of x is equals to a or c. So you can go through class 11th book for getting the revision of the different types of functions and their graphs. Now if I will compare the concept of the term relation in mathematics has been drawn from the meaning of the relation in English language, according to which two objects or quantities are related if there is a recognizable connection or link between the two objects or quantity. If two objects are associated with each other, then we can say there is a relation between the two quantities. Now, let A be the set of the students of class 12th of a school and B be the set of students of class 11th of the same school. Then some of the examples of the relation can be A is a brother of B. This is also this set. You can say the two elements are related with the relation that A is a brother of B. Then A is a sister of B. Age of A is greater than age of B. Total marks obtained by A in the final examination is less than the total marks obtained by B in the final examination. Then A and B lives in the same locality, and so on. We can make different type of relation. However, abstracting from this, we define mathematically a relation R from set A to set B as an arbitrary subset of A cross B, and that you people have already done in class 11. That relation is always a subset of the A cross B, and what we call A cross B as Cartesian product. Then this is again we have done in class 11th. If AB belongs to R, we can say A is related with B. We can write A is related with B, or we can write AB belongs to R. Both have the same meaning. We say A is related to B under the relation R, and we write as A is related to B. In general, AB belongs to R. We don't bother whether there is a recognizable connection or link between A and B, as seen in class 11 functions. If A belongs to B, then there is some relation between A and B, that is A is related with B. And in class 11th we have done function is a special kind of relation. Okay, so in this chapter we will study different types of relations and function, composition of function, invertible functions, and binary operations are not in our syllabus now. So let us discuss with the types of relations. In types of relation, so in this section we will discuss different types of relation. There are two trivial relations. Trivial relations means there are two relations that are, one is empty relation and another is universal relation. You can have a hint from the names. Empty relation, in which no element is related with the other element, and universal, in which every element of a set is related with the second set. So we'll give you the definition, and after that we will proceed toward the examples. So if I will take an example, I will take the example that is given in the book. A is equals to 1, 2, 3 and 4. Then I am writing how the relation is defined, AB, such that A minus B is equals to 10. So you can see that no element of the set A satisfies the, no two elements of the set A. If relation is defined from A to A, no two elements of set A satisfies the condition that A minus B is equals to 10. The difference of these two numbers can never be equal. Any two of these number cannot be equals to 10. So R is equals to 5. This is your empty relation. I will give one more example. Like suppose A is the set of, I will write A, set of students studying in GCW Gandhinagar, or you can say Women College, ठीक है. And how I am defining the relation? R is defined, A is a brother of B. As this college is for only women, so A cannot be a brother of B. So here again your relation is 5. So this is an example of your empty relation. Now let us proceed toward the universal relation. For universal relation, I will write the example that R is equals to, I will take the same set, A is equals to 1, 2, 3, 4, and I will define R is equals to AB such that modulus of A minus B is greater than equals to 0. Modulus of A minus B is greater than equals to 0. Then you can see every element of this set satisfies the condition. So this type of set will be your this type of relation will be your universal relation. This is your universal relation, and the relation is satisfied by all the elements of the ordered pair. You can take any two elements and this satisfies the condition, so you can say it is the universal relation. So this will becomes your universal relation. Okay. Now I will again take an example that suppose I will take A is set of students studying in APS. Set of students studying in APS. Suppose I will write Jammu. APS Jammu. Then if I will take the relation R, it is student AB such that A and B study in APS Jammu. So as I have taken the set of students studying in APS Jammu, so this relation is your universal relation, because every two elements, if we take any two elements, this satisfies the condition that they are studying in APS Jammu. So let us proceed toward the definitions now. So you can consider these two extreme examples led us to the following definitions. First is your empty relation and another is universal relation. What is your empty relation? Empty relation, a relation R in a set A is called an empty relation if no element of A is related to any element of A. That is, no element of the ordered pair are related to each other. And the relation R in set A is said to be the universal relation if each element of A is related to every element of A. That is, R is equals to A cross A. So both these relations are sometimes called trivial relations. These are also called the trivial relation, and they have given you the example also. Let A be the set of all the students of boys school. Show that the relation R in A given by, I have taken this similar example like this. A is a sister of B, as this is a boys school, so there is no two student that satisfies the relation that A is a sister of B. So this is an empty relation. And R dash, the difference between height of A minus B is less than 3 meters. So again this will be your universal relation, because this will be satisfied by all the elements of the ordered pair. Solution is, since the school is boys school, so no student of the school can be a sister of any student of the school. Hence R is equals to 5, showing that it is an empty relation. And it is also obvious that the difference between height of any two students of the school has to be less than 3 meter, and this shows that R dash is equals to A cross A is the universal relation. Clear? Now there is a remark written on your book that in class 11th we have seen two ways of representing the relation. One is roster form and another is set builder form. Roster form is when you are writing the relation in curly bracket separated by the commas. This is roster form. And if you will write the relation in terms of statement, for example, if I will write R is equals to AB such that you can take any relation A is equals to B plus 1 or anything like that. If you write it in the statemental form, then it will be your set builder form. So you have two types. You mentioned the relation in two forms, that is roster form and set builder form. So if the relation is defined by this, can be expressed if and only if B is equals to A plus 1 by Benny author. Sometimes set this defined by this is also expressed as A is related to B if and only if. Sometimes they will write the relation like this directly, or sometimes they write it in the statemental form. So we also use this notation as and when convenient. We will use the notation according to our question. So if AB belongs to R, we can say A is related with B, and we denote it by using these symbols. So that is we people have already done. Now we are proceeding toward the very important topic, that is equivalence relation. ठीक है. You people have two questions, one example and one exercise question in class 11th, where you people have to show that it is a equivalence, reflexive, symmetric and transitive. So in class 11th, so let me proceed toward the equivalence relation. Before proceeding toward the equivalence relation, we people have to proceed toward reflexive relation, symmetric relation and transitive relation. This is going to be the very important part, because you will definitely get a question from this topic. So we will start with the reflexive, symmetric and transitive. So what is reflexive? If I will use the term reflection. Reflection is whenever I am seeing myself in the mirror, I will see my reflection. It is not I am able to see yours reflection or somebody else's reflection. I will see only my reflection. So I will relate the reflexive relation with the term reflection, that your A is a relation is said to be reflexive if A is related with A, that is every element should relate to itself. Every element should relate to itself. Clear? So we can write A is related with A, or A belongs to R. Okay, for all A belongs to your set A. So this is the definition of the reflexive relation, that every element should be related to itself. Next, we people have symmetric relation. We have symmetric relation. If I will use the term symmetry, what does it mean? Symmetry means equal. Okay, so if symmetry means if I am giving 5 rupees to you, then you have to give 5 rupees back to me. Clear? So this is something related with the term symmetric relation. So in symmetry, we will take if AB belongs to R, that means BA should also belongs to R. I can say if A is related with B, that means B should be related with A, for AB belongs to your set A. So this is the definition of the symmetric relation. Then next we people have transitive relation. Transitive relation means, so in transitive relation, what does we have? We have AB. We will take if AB belongs to R and BC belongs to R, implies that AB belongs to R and BC belongs to R, implies that AC should also belongs to R. That is, I can say if A is related with B and B is related with C, it is clear that A is related with C. So this is the definition of the transitive relation. Now let us proceed toward the definitions. Underline them on your book. So this is reflexive relation, that if A belongs to R, for all A belongs to A. Symmetric, if A1 A2 belongs to R, A2 A1 should also belongs to R. Transitive, if A1 A2 belongs to R, A2 A3 belongs to R, then A1 A3 should also belongs to R. Now we will reach toward the term equivalence relation. Equivalence relation means a relation which is reflexive, symmetric and transitive is your equivalence relation. Clear? Now we will proceed toward few of the questions, examples and questions. Now you people consider that this chapter is the easiest one. How? You must understand the definition. Students understand the question, but they lack in the concept that how to write the question. This is the point where they lack, that is how to write the question. Concept is clear, they understood that is reflexive, symmetric and transitive. The important part is the written part, that you people have to write each and every step in such a way that the answer is self-explanatory. that examiner or checker don't need to think about anything. Just look at your answer and the answer speaks itself. So you have to write in that way. Okay, so you have to learn how to write the answer. I will take an example, that is, this is your example second. In example second, the question is, let T be the set of all the triangles in a plane with the relation in T given by how the relation is defined. T1 is concurrent to T2. This is how the relation is defined. You have to show R is an equivalence relation. What you have to show? R is an equivalence relation. So in back of your mind, you must be clear that I have to show that this relation is reflexive, symmetric and transitive. What is reflexive, what is symmetric and what is transitive? So firstly, I will take the case reflexive. So you people know, before starting the question, firstly you people have to write the relation R is equals to T1 comma T2 such that T1 is concurrent to T2. Okay. Now for reflexive, since every triangle is congruent to itself, that is T1 is concurrent to T1. T1 is concurrent to T1 implies that T1 comma T1 belongs to R. Therefore R is reflexive. Here you will write for all T1 belongs to the set T. So this is how you people have to write the case of reflexivity. Reflexive relation, since every triangle is congruent to itself, that is T1 is congruent to T1, so this implies T1 comma T1 belongs to R. T1 comma T1 belongs to R for all T1 belongs to T. Therefore R is reflexive. I hope it is clear. Now we will proceed toward the second step, that is transitive. So for transitive, this must be clear in your mind. I will write for symmetric. For symmetric, definition must be clear in your mind. So we will take let T1 comma T2 belongs to R. So back in your mind, it should be clear that we have to show T2 comma T1 belongs to R. So if T1 T2 belongs to R, what does it mean? It means T1 is concurrent to T2. You have to write for all T1 comma T2 belongs to T. Okay. So what does it mean? This implies that T1 is concurrent to T2. Now if T1 is concurrent to T2, I will write T2 is concurrent to T1, because if triangle T1 is concurrent to triangle T2, then triangle T2 should also concurrent to triangle T1. This implies that T2 comma T1 belongs to R for all T1 comma T2 belongs to R. So we have taken T1 comma T2 belongs to R, and we have shown that T2 comma T1 belongs to R. Therefore R is symmetric. Is it clear? Now let me proceed toward the next question, next part of the question, that is your transitive. So for transitive, I will take, you are very much aware about the definition, let T1 comma T2 belongs to R and T2 comma T3 belongs to R for all T1, T2, T3 belongs to T. So if T1 comma T2 belongs to R, what does it mean? Means that T1 is concurrent to T2, because this is how the relation is defined. And if T2 comma T3 belongs to R, what does it mean? It means T2 is concurrent to T3. So if T1 is concurrent to T2 and T2 is concurrent to T3, implies T1 is concurrent to T3, implies that T1 comma T3 belongs to R. T1 comma T3 belongs to R. Therefore R is transitive. R is transitive. We have taken T1, T2 belongs to R and T2, T3 belongs to R, and we have proved that T1, T3 also belongs to R. Therefore R is transitive. And now we will write, since R is reflexive, symmetric and transitive, and hence it is an equivalence relation. So we will write, since R is reflexive, symmetric and transitive, hence it is an equivalence relation. So this is the steps how you people are going to write the solution. I hope it is clear to all. So you must learn how to write the steps of the question. So I will take one more example. Then this example is example third. Let L be the set of all the lines in a plane, and how the relation is defined. L1 is perpendicular to L2, and you have to show that R is symmetric but neither reflexive nor transitive. Okay, so I will start with how the relation is defined. L1 comma L2 such that L1 is perpendicular to L2. So you can write reflexive, since no line can be perpendicular to itself, therefore L1 comma L1 does not belongs to R for all. This is the symbol of for all. L1 belongs to L. For all L1 belongs to L, therefore R is not reflexive. R is not reflexive. Next we will proceed toward the symmetric. So I will take, let L1, L2 symmetric. For symmetric we will take, let L1 comma L2 belongs to R. This implies that L1 is perpendicular to L2. Here you have to mention for all L1 comma L2 belongs to L. So this implies that L1 is perpendicular to L2. If line 1 is perpendicular to line 2, if line 1 is perpendicular to line 2, then line 2 is also perpendicular to line 1. So line 2 is perpendicular to line 1, implies that L2 comma L1 belongs to R. Therefore R is symmetric. ठीक है, R is symmetric relation. Clear? Now let us proceed toward the next, that is transitive. For transitive, what we people have to do? For transitive, we people will take let L1 comma L2 belongs to R and L2 comma L3 belongs to R for all L1, L2, L3 belongs to L. No, I will write here before writing the steps. I will write here, suppose L1 is perpendicular to L2 and L2 is perpendicular to L3. Then what you people conclude? You people have concluded that your L1 is parallel to L3. So I will write it here that L1 is perpendicular to L2 and L2 is perpendicular to L3. L2 is perpendicular to L3. L2 is perpendicular to L3 implies that L1 is parallel to L3 implies that L1 L3 does not belongs to R. Therefore R is not transitive. So I hope it is clear to you all. So this was asked in the question that we have to show that this relation is this relation is symmetric but neither reflexive nor transitive. So we have shown. So you will write, therefore this relation is symmetric but neither reflexive nor transitive. Now we will proceed toward few exercise question where we will prove the same, and I will solve this question tomorrow because you people have to revise whatever you people have done in today's class. So go through the proper revision of the chapter up to the topic we people have discussed. Write the important points on your notebook, solve the questions on your notebook, and rest of the questions we will discuss tomorrow. Thank you so much, and please go through the important revision part of your class 11th also. Thank you so much. That is all about today. God bless you all. In next video we will cover the next topic and with next questions. Thank you so much. God bless you all.